Several of the most important positive feedback processes involved in climate change are the melting of the polar ice caps, which decreases the amount of reflectivity of the sunlight because the water or land underneath the ice is dark and absorbs heat, which melts more ice, which absorbs more heat, which continues. Another positive feedback process that's kicking in is the loss of the rainforests, particularly in the equatorial regions of our planet. Rainforests produce clouds. They pump huge quantities of water up through their bodies, and the water evaporates from the leaf surfaces, and that evaporated water contributes to cloud cover, and clouds are white on top, reflecting sunlight. So as we lose the rainforests, we lose the cloud and the clouds over those areas, and heating accelerates. Another major positive feedback process involves the melting of the permafrost regions, particularly in the northern parts of North America and Eurasia. Some 20% of land surfaces on this planet are in permafrost, places where the ground is permanently frozen year-round. Those permafrost areas are melting now, and the organic matter in those areas are decomposing with the help of bacteria called methanogens, which produce methane, one of the greenhouse gases, as a waste product, which further heats the region, which melts more permafrost, which further heats the region, which melts more permafrost, methane increases, etc. There's one other very important key positive feedback process that I'd like to speak of, and it involves an organism, a marine algae, called Aemiliania huxleyi, or Ehux for short. Ehux is one of the most important life forms on the planet, one of the most important components of the Gaian climate regulation system. It's a marine algae that plays two very important roles in regulating climate. First, it produces a chemical compound called dimethyl sulfide, or DMS for short. It's a waste product produced by Ehux, such that when it volatilizes, when it's released into the atmosphere, water molecules are attracted to it. Clouds, again, are white on top, and so cloud cover on oceans, especially in those tropical oceans, reflects sunlight, cooling the region. Anything that impacts the health of Ehux in the oceans will reduce cloud cover and cause more heating. The other important role that Ehux plays is in pulling carbon dioxide out of the air and the water. Carbon dioxide dissolves in the water and it's converted into a compound called carbonates. Ehux uses carbonates, specifically calcium carbonate, to build little shells for itself, so that the shells of Ehux are literally a mineralized form of carbon dioxide. When Ehux dies, those calcium carbonate shells sink to the ocean bottom, where they build up in layers literally miles thick called limestone. So Ehux, as it turns out, is one of the bilge pumps for CO2 on the planet. It helps pull CO2 out of the atmosphere. And anything that impacts Ehux in a negative way is going to seriously impact the ability of our planetary system to regulate its CO2 content. And that's what's happening now with the heating of the oceans. The oceans are also acidifying because as CO2 dissolves in the water, carbonic acid is produced. As we liberate more CO2 into the atmosphere and into the water, the oceans become more acidic, which reduces the ability of Ehux to do its role in removing carbon dioxide, which leaves more carbon dioxide in the atmosphere, which causes the oceans to become more acidic, etc. To truly understand global heating and climate regulation, one must pay close attention to the natural processes that cycle these carbon compounds. both the processes that the natural processes that increase CO2 and methane, but equally as important, understanding what pulls those carbon compounds out of the atmosphere. And the removal of the carbon molecules from the atmosphere requires quite a long time, decades in most cases. Let me add another thing or two about the extreme importance of the melting of the polar ice caps. Remember again that ice is white. Ice in the polar ice caps, the North Pole, the Arctic region, and the South Pole, the Antarctic region, those large ice masses reflect 80% or more of the sunlight coming into the planet. That significantly cools those regions. It keeps the polar regions cold. So as we lose the polar ice caps, we lose that reflectivity, and the darker material under the ice, which is in the northern regions, in the Arctic region is mostly seawater, dark seawater, and in the southern regions underneath Antarctic ice is landmass. Those are dark, which absorb as much as 80% of the sunlight or more. That heats the region, which melts more ice, which exposes more dark material, which heats the region, which melts more ice. That's the positive feedback process.